Okay, welcome back. It's 7.4, which is reciprocal functions. And continuing on with the concept of functions, remember that we are graphing these. So we are looking at drawing the graph of a reciprocal function. So what is a reciprocal function? If you remember reciprocal from junior high, if I take 2, the reciprocal of 2 is 1/2. So all we're doing in this case is understanding that you are just putting it 1 over whatever the number is. So the reciprocal of 3/2 in this case works out to be 2/3. Now how does this apply to functions, and how would we write them? So starting with the original function, which is the simplest one, which would be a linear one from grade 10, if I start with the function y is equal to x, then the reciprocal of that would be y is equal to 1 over x. And what we're going to do is take a look at these and understand something a little bit about the graph and how you would draw it, understanding that what you are going to do is try and do these graphs without using a graphing calculator. Now, some of the terms that are going to come up is something called an asymptote. An asymptote is like a wall or a barrier, and it really refers to the MPVs that we talked about earlier, which is the non-permissible values, because as soon as you deal with reciprocal functions, in this case we have variables in the denominator position, which, and if you recall, we cannot divide by 0, and we'll take a look at what happens when, in terms of using these when we start to graph them. The second thing we talk about is invariant points. Now, understanding that these are the points that don't change from the original graph to the reciprocal functions, and we have to identify those when we're graphing them. And the third thing we're going to take a look at is the behavior of the graph as it goes. Now, understand that in reciprocal functions, okay, when you take the reciprocal of 2, it becomes 1/2. Which is a smaller number, but when you take the reciprocal of 1/2, it becomes 2. So the reciprocal of a small number is just is going to become a larger and larger number. The reciprocal of 1/10 becomes 10. The reciprocal of 1 over 100 becomes 100. So you can see, as if you start with a small number, you take the reciprocal of it, it becomes a very large number. And that's going to be, if you look in your book, it's the behavior of the graph that we will look at. So let's take a look at the first one, which would be y is equal to 2x plus 5. And we will look at it at the reciprocal function, which would be 1 over 2x plus 5. I've drawn the table of values that applies to the linear graph, and if we look at the reciprocal function here and taking a look at it, okay, we are just going to take the reciprocal of this, which would be -1 over 1, which would be still just -1. This would be 1 over 1, which is 1. This would be 1/3, 1/5, 1/7, and 1/9. Okay, these are all taking the reciprocals. If you take a look at it, there's a couple things that stand out here. These numbers are the same. So you can take a look at the invariant points, which would be -3, -1. And on the reciprocal function, it would be -3, -1, which is exactly the same point, which becomes an invariant point. Now, something else that stands out here is if I choose -5/2 here. If I choose -5/2 for my original function, if I replace this, this becomes 0. Now, taking the bottom of 1 over 0, we can't do this, so this becomes undefined. Now, that undefined situation is called an asymptote with reciprocal functions, and I will show you what it looks like on the graphs, because in this case we will identify that particular value, which we understand it is a line or the barrier that we cannot use this because it gives us an undefined situation. So let's take a look at the first example here, and I've started with the graph of y is equal to 2x plus 5, and I've already drawn it in with the table of values that we have from before, and I've indicated some of the points here. Now what we want to do is be able to draw the graph as y is equal to 1 over 2x plus 5, and I'll take you through the steps. So step 1, the first thing we identify is the asymptotes. What are they in this case? Now these are the cases in the asymptotes. Remember that at the x-intercept right over here, okay, that is the point where if we replace it in the original function, we get an x-intercept there, and that becomes the asymptote or the non-permissible values. And what we do is we indicate that with a broken line at that particular point, which looks like this. Now that's indicating that I cannot use this particular point because it becomes an undefined situation in the reciprocal. So I indicate that. Now remember, the asymptotes of the reciprocal are the x-intercepts of the original. Okay. The next thing that we identify is the invariant points. Now, the invariant points are the points they occur at two particular numbers here. When y is equal to -1 and y is equal to +1. Those become the invariant points. Now, what I generally have students do is indicate this with a straight line of y is equal to -1. So I draw it like this to indicate where that graph is going to touch, which is right there, and right here. Those become the invariant points. At -1, at y is equal to 1, and y is equal to -1. Now, to draw the graph, okay, what I indicate from here, and this is dealing with the behavior of the graph, and basically, if you remember from, the earlier explanation, I place my pen on the invariant point as the x values or the y values increase here. Okay, the x values decrease. All right, go from there with that knowledge. And as they go from this point, they decrease, they increase here. Now, remembering that you cannot touch the asymptote. Now, for reciprocal graphs, okay, and this only happens in Math 20 because we're just taking the reciprocal graph over here and there's no variable on top, but the y equals 0 is another asymptote for all the graphs. So, doing the same thing with the bottom part, okay, placing my pen on the invariant point, as these increase, this will decrease, and as those increase, we go the opposite that way, and that decreases. And what I've drawn here is the reciprocal function for the graph y equals 2x plus 5, which is y is equal to 1 over 2x plus 5. Now, looking at a little more complicated question, which is we're looking at a quadratic here. Now, remember, I'm not going to give you the function so that we can't use the calculator. So in this case, you are given just the graph, and I will call this graph simply y is equal to f of x. And what we are doing is trying to draw the graph of the reciprocal, which would be 1 over f of x, and this will be written or done in pink. So step 1, first thing we want to do is indicate the asymptotes. Now remember from before, the asymptotes are drawn at where we're looking at the x-intercepts of the original. So we're looking for the x-intercepts. Now here you can see they're drawn right over here. Here's an x-intercept and that's an x-intercept. So I will draw the asymptotes in blue. Okay, remember those are the barriers where the graph cannot touch. The next thing I will do is indicate where the invariant points are. Where are the invariant points? Now the invariant points occur when y is equal to plus or minus 1. So here at 1, I will follow the graph and indicate right there. Follow the graph on y equals 1 and indicate the varying points right there. And I'll do the same thing for y is equal to negative 1, which would be right here and right here. Now those 4 points are called the invariant points. Now basically we do exactly the same thing. Okay, so from right over here, as this increases, now remember that the other asymptote is the line y equals 0, and that's simply because that applies to the reciprocal function. So as this graph increases, the reciprocal function will decrease. As this goes downwards, the reciprocal function goes upwards. Okay. Now, doing the same thing on this side, as this increases, this decreases. As the original decreases, the reciprocal will increase. Now, over here, I have the vertex, which is 3, negative 4, and remembering the reciprocal will take the reciprocal of the y value, which becomes 3, negative 1/4. So that would be somewhere right there. So going from here, as this increases in the original, the reciprocal will decrease. Remember never to touch that asymptote. It'll come upwards through the vertex. As this one increases, it decreases and follows the same graph. So as a result, those are the behaviors of the graph near the asymptotes. You have the vertex drawn in here, remembering that we're taking the reciprocal of negative 4 to get negative 1/4. Understand it will not touch the line y equals 0. So what you have drawn there is the reciprocal function. Now understanding, and just to review, remember the asymptotes are the x-intercepts, and the invariant points occur at y is equal to plus or minus 1. Okay, hopefully this helps, and good luck with your homework.